talk about the compounds methane and boron trifluoride. Methane, in other words, CH4, is made up of two atoms, one being carbon and the other one being hydrogen. Now, as you can see, carbon has 1 and hydrogen has 4, since the little 4 is next to the H. Now let's go take a look at the periodic table. Carbon is in group 4, right here, and hydrogen is in group 1, right up here on top. Now, the best way to find out a lot about an atom is to draw a Lewis dot structure. And to draw a Lewis dot structure, all you need to know is what compound it is, and all you need to do is look up the two different atoms and see what group they are to see how many valence electrons they have. So for carbon, we'd go to the periodic table, and since carbon is in group 4 right here, we know that it has 4 valence electrons. Now hydrogen is in group 1 right up here, which means that it has 1 valence electron. Now, in order to be able to identify all the different valence electrons in a compound, we need to add the valence electrons of the individual different atoms. So we know that carbon has 4 valence electrons and hydrogen has 1. But since there are 4 different hydrogens in this methane compound, we need to multiply 1 times 4, which equals 4. Now we're going to add those 4 carbon valence electrons and those 4 valence electrons from hydrogen, 4 plus 4, which makes 8 valence electrons right here. So now we know that in total there have to be 8 valence electrons in our Lewis dot structure. The next step would be to see which element would be in the middle of our diagram. Now usually it would be the atom which is written first. In this case it would be carbon right here. So we put a C right in the middle, go up, and hydrogen is next, and there are 4. So we write 4 H's around the carbon. 1, 2, 3, and 4. Now we're going to make bonds, and those bonds each represent 2 valence electrons that are being shared. 1, 2, 3, 4, and 2 valence electrons each, which makes 8. Now, for hydrogen, we know that it has 1 valence electron. But we also know that it wants 2 valence electrons for a full outer shell. Hydrogen would be very happy if it had 2. We also know that carbon would love to have, well, it has 4 valence electrons, but it would love to have 8 valence electrons. That would make carbon very happy. Now, we have to count if we have 8 valence electrons, which we do in this case, and we can see in this diagram that each hydrogen atom has 2 valence electrons now that it shared them with the carbon, and carbon has 8 in total. So this Lewis dot structure diagram is complete. Now, the next step we could do is see what shape it is. So first of all, we look how many bonds there are. We see that there are 1, 2, 3, 4 bonds. But there are no lone pairs, because lone pairs are leftover electrons which have nowhere to go, which are then put around the central atom. So now we know it has 4 valence electrons and 0 lone paired electrons. And this equals the shape tetrahedral. Now, if you don't know this information by heart, there's also a page where you can just look it up. And here, I'm going to draw it again, is tetrahedral. And coincidentally, it says CH4 right here, so it's another fact that this is the right one. And it says it's 109.5 degrees, which happens to be right. There you go. So this is the bond angle right here, meaning that each hydrogen atom is 109.5 degrees apart. This also means that it's a non-polar bond, because each hydrogen atom cancels each other out, making everything neutral and not have a higher polarity than the other one. So since we know that it's a non-polar bond atom, we know that for the van der Waals laws, right here, that it's not dipole, or any of these other ones. We know that since it's non-polar, that it's London dispersion. Meaning that that at a certain second, the electrons over here or down there might move to right or left, causing certain parts of the compound to be more positive or negative than during other times. So yeah, this is information about methane. Now we'll move on to boron trifluoride right here. Now, the name for boron trifluoride would also be BF3. Now, the name itself, boron trifluoride, right up here, the written name, already gives us a hint to whether it's covalent or ionic. We can tell that it's covalent because of the second part of its name, which starts with a tri. This is a prefix. Only covalent bonds have these. So right here, boron trifluoride. There you go, sorry I misspelled that. Prefixes are basically to make our lives easier. They tell us whether there are 1, 2, 3, 4, or 5, or whatever number of this kind of atom in the compound. So since there's nothing in front of boron, we know that there's just one. It's an invisible one right now. And here, it says tri, so we know that there are 3 fluorines. So let's go take a look at the periodic table. So boron is right here, fluorine is right over here. Now, just as with methane, if we want to do the Lewis dot structure, we need to look at what groups they're in. That way, we can tell how many valence electrons there are, and that way we can work out how this dot structure is going to look like. So we go look at boron. Boron is in group 3. So let me write that down real quick. Boron is group 3. Fluorine, on the other hand, is in group 7. Now, this also tells us that fluorine is a lot more greedy for electrons, since it only has one more to get in order to reach a complete outer shell, and that's what all the atoms try to be. And boron isn't as greedy for them, since it has to get rid of 3, which is a lot more work than fluorine. There's also another hint to why boron trifluoride is a covalent bond, because they are both non-metals since it's on this side, on the right side of this line right here. And we know that covalent bonds are usually two non-metals combining, and ions are a non-metal and a metal combining. So this is another hint. So for fluorine, it's 7. Now, once again, we have to add these together to know the total amount of valence electrons. But before we do that, let's check if there are more than one boron or fluorine in the compound. So for boron, there's only one, so we can keep 3, this is good. And fluorine has 3, with the tri-fluorines. So we have to multiply the 7 by 3, which equals 21. And now we simply add 3 and 21 together. So 3 plus 21 equals 24 valence electrons. Now once again, we look up here which atom is in the front, which happens to be boron right here. So this is going to be in the middle, B. And we'll have 3 fluorines surrounding it. 1, 2, 3. And we'll combine these bonds together again. So 1, 2, 3, making 1, 2, 3, 4, 5, 6 valence electrons. Now we've already created these bonds, but we still have 24 minus 6 equals 18 valence electrons left. Now we have 18 to distribute around the compound. Now we'll just start like this. We'll go 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Now we've completed the Lewis dot structure. All of the atoms are happy. All of their outer shells are full. So this is the completed Lewis dot structure diagram for boron trifluoride. Now our next step would be to distinguish what shape it is. So since boron trifluoride has 3 different bonds and 0 lone pairs, we know that it's a trigonal planar. Now we can go double check on this page, right up here. 3 bonding pairs and 0 lone pairs, and it's 120 degrees. So I put that down right here. Now this tells us how far apart all of these atoms are, always exactly 120 degrees. Now this also tells us that it's a non-polar compound, since they all cancel each other out and they're all far apart equally. And just like with methane, we now know that it's London dispersion. Since at milliseconds these will be positive or negative charged. Alright, there you go. This is the information for boron trifluoride and for methane. Now, if I had to compare these two, there's actually not a lot of differences between them. They're mostly very similar since they're both covalent. They both share their electrons. They don't give them to each other, since that would be ionic. They are both nonpolar, and they both have London dispersion, but not any of the other van der Waals laws. Yet there are a few differences, one of them being that boron trifluoride is a trigonal planar, and methane is a tetrahedral, since methane has 4 sharing bonds and boron trifluoride only has 3. Now, naturally, this changes the angle of the bonds as well, boron trifluoride having 120 and methane having 109.5. But overall, they are 2 pretty similar molecules. Thank you very much for listening, and goodbye.